So we've already learned a little bit about the behavior of these polynomials based on their end behavior, based on their leading coefficient and their degree. Well, we can find a little bit more based on their x and y intercepts and the multiplicity of the roots, which, don't worry, I'll explain what that is in just a moment. So let's see if we can find the x-intercepts. Well, the x-intercepts are where y equals 0. So I set this equal to 0, but it's already factored. So these multiply to 0, so these factors have to equal 0. Well, this one will never equal 0. This would be -5 to make this equal 0. This would be +7 to make this equal 0. Now to find the y-intercept, it's the opposite. I have to set my x equal to 0. Now to set my x equal to 0, this is 2. 0 plus 5 is 5. 0 minus 7 is -7. So 10 times -7 is -70. All right? So let's take our end behavior. Let's combine it with these 3 points, and let's see if we can come up with a sketch. Okay? Now, again, if you wanted something that was really detailed, shove it in graphing calculator, you're good to go. But again, we want just a gut feeling about what our behavior is going to be. So let's throw these points in. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And really far down here, we've got -70. And well, what's the behavior going to be like? Well, we know this is degree 2, so it's like this. We know it's positive, so it's going to be like this. So we know this is going up this way, this is going up this way, and ignore the little point of inflection there, okay? This is approximately how this guy's going to look. Now, let's try something a little trickier. Ooh, this is a nasty one right here. So, first of all, we need to come up with how many degrees this guy is. Now, whenever I write something like this, people tend to pick up on this and this, but they ignore this because they don't see any parentheses. Parentheses don't change anything, but hopefully this makes you realize that that's another root there. So what's the degree of this guy? Well, we've got this guy, this guy, this guy. Is it degree 3? No, this guy shows up twice. So there's this guy, this guy. There's this guy shows up 3 times. There's this guy shows up twice. So we wind up having 1, 2, 3, 4, 5, 6, 7. This is degree 7. Now, you shouldn't have to do that. We just say, okay, 1, 2, 3, 4, 5, 6, 7. So our degree is 7. Our leading coefficient is -2. So if it's degree 7, we're looking at something like this. If it's negative, then we kind of have to flip around, okay? Let's find our x-intercepts and our y-intercepts. Well, our x-intercepts are our 3 roots. So we should have 0, 0. We should have -3, 0, and 4, 0. Now, this is a double root. Okay, that root shows up 2 times. This is a triple root, shows up 3 times, and this is a double root, shows up twice. Now, what's our y-intercept? We plug 0 in for our x. So -2 times 0 squared times 3 cubed times -4 squared. We don't have to think, I'm multiplying by 0. So this is going to be 0. We already saw that, but So these are our x-intercepts. This is our y-intercept. So when we want to look at our graph, we can plug in an x-intercept here, x-intercept here, 1, 2, 3, 4, x-intercept here. Our y-intercept is here. Now we know that we're going like this, okay? So at some point, we're going to be going, oh, sorry, it's negative, so it goes the other way. Some point we go this way, and something happens in the middle. Now, to help us out here a little bit, we can use the multiplicity, okay? Now, what the multiplicity shows us is kind of what happens at these points. Now, let's look at the first one, which is x plus 3. That's this guy right here. If you see one that's third power, that's cubic, what you wind up with is a point of inflection there. So instead of going straight through, you're going to see it kind of bend a little bit there. You're going to see that point of inflection. And then at this one, it's squared. So we know it's got to turn around at some point. But instead of plowing straight through, if it's power 2 or 4 or 6, it's going to be a point of tangency. It's going to hit that and bounce off. Okay, so we have a point of tangency there. And then we get to x minus 4, so we get this guy. This is also even, so we should have another point of tangency. Now, these guys actually go a lot lower than this, okay? But we now have a sketch of what our graph looks like based on end behavior and multiplicity of our roots. How many times our roots show up? Let's take a look at one more. So let's find the degree. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 plus 1 plus 5. Okay, so we have 8 roots. So that's even. So that means like this, except for the leading coefficient's negative. So we're going to look like this. So let's find our x-intercepts, and let's find our y-intercepts. So x-intercepts should be -1, 1, 7. Y-intercept, remember we set our x equal to 0. So -5, 1 squared, -1, -7 to the 5th. We get something rather large, or in this case, something really low negative. I'll calculate that later. But that's how you would find your y-intercept. Okay? Now let's graph this. Our roots again are at -1, 1, and 7. 1, 2, 3, 4, 5, 6, 7. Okay, so there's where our roots are. That's where our x-intercepts are. And remember, we're doing this. So this is going that way. And since it's +1, this is going to be a point of tangency because it's an even multiplicity. And then when we hit this, this is an odd multiplicity. So it's just going to shoot through. If it was like 3rd or 5th, it would do the point of inflection thing, but this one just plows through. And then finally, x minus 7 to the 5th. This guy is going to do a quick point of inflection here as it goes down. Now, there's only one mistake here. We know my y-intercept is really, really, really low. So we know this is going to go way down and back up. So, excuse my horrible drawing, but that is a sketch of what this guy is going to look like, just based on end behavior, roots, and multiplicity. So now you have a good idea of how these work. You have a gut feel for them.